Hey, Callie, I'm just jumping in because you're on mute.
Hi, can you guys hear me now? Oh, perfect. Cool. Yeah, so hello and welcome to DevSecCon Cape Town. We are a chapter of the global DevSecCon community. And yeah, what we do is we actually encourage developers and basically teach developers about application security. So coming up in today's live stream, we actually will be joined by Graig Risi, who will be talking about unlocking code confidence, building effective quality gates in CI pipelines. But before we dive in, so we quickly just want to introduce ourselves as the DevSecCon Cape Town chapter leaders. So yeah, I'll basically start off and to introduce myself. So I'm Callian. I'm the co-leader of the DevSecCon Cape Town chapter, and I currently work as a DevSecOps engineer. So, so just a bit about myself. So I have a background in web and application development, and yeah, so I actually that's actually where I started growing a passion for application security, and I just started going a bit more deeper into application security and implementing it into the systems that I worked on, as well as testing what I've learned in bug bounty programs. So how it actually came about, I stumbled upon a ethical hacking and website hacking course, so which basically taught me the fundamentals of application hacking. So and then I basically just fell in love with it. And yeah, because I was a developer, I basically introduced what I learned in the systems, as well as fixed the vulnerabilities that I found. And yeah, actually, so that's one of the things that I realized as well. As a developer, I was never taught how to write secure code, and that's actually how I got into DevSecOps. Yeah, and basically to work with development teams, and yeah, to basically assist them with building secure applications, as well as integrating security throughout the software development lifecycle. So that is something that I'm passionate about. And yeah, but that's basically a bit about me. So please feel free to reach out to me on LinkedIn or on Discord, or just if you look for DevSecCon Cape Town, you will basically find my information there as well. I will give it up to Kimberly as well to introduce her.
Thank you, Callie. Hi everyone, I'm Kimberly, a co-leader of the DevSecCon chapter in Cape Town. I also have over 10 years experience with in the overall software development and application security space. And I've been a strong advocate for DevSecOps for over 4 years now. And I've seen the benefits implementing it in companies before and currently where I work, heading up the application security and DevSecOps programs. Thank you.
Thank you, Kim. Appreciate it. Yeah. So let's get started. What I'm gonna do is I'm quickly just gonna share the slides as well as our agenda for today, and just before we get started, so that we just talk about a bit about the agenda and what we will be doing. So we will actually be so just a bit about the agenda. We the welcome and as well as the introduction. So next we will actually do a we did the introduction. So next we will actually do a quick quiz. Um, Yeah, so I will quickly just add it in the chat. So we're just gonna do a quick quiz on just a bit about what DevSec ops is and what people actually think. So more about like myths or facts about DevSec ops. So I'm quickly just gonna add the link in the chat. So yeah, so let me quickly just open it on my side as well so that you guys can see how it looks. So please feel free to open the link in the browser. I can see that a couple of Chris and Steven already joined. So let me quickly just open that view as well. Thanks. I see I actually see a couple of additional users joined. I think we'll give it about 30 more seconds. Then we're basically going to start with the quiz. Okay, so how the quiz is actually going to work before we get started. So you guys will basically, it's just 3 questions where you basically have to read the question and basically answer and say if the statement is a myth or a fact, but it's all related to DevSecOps. So what I'll do is I'll start it and you will have 30 seconds for each. See some nice interaction. Oh, perfect. Yeah, so we'll go on to the next one. You guys are quick. Chris is leading, then Nina. Oh, perfect. Let's quickly have a look at the leaderboard. Cool, let's see who won. Chris. Congratulations, Chris. Yeah, so what we will do is, let me quickly just close this side. Congratulations, Chris. So what we will do is, Chris, you can just reach out to me and then we will send you Graig Risi's book. So the quiz winner. Yeah. So the quiz winner will actually win Chris Risi's book. So yeah, Chris Risi is our guest speaker today. And yeah, and congratulations again. Perfect. So to carry on, with our program. So we will give it over to Graig Risi, and for him to introduce himself and to do his talk as well.
Perfect. Thanks so much, Kallie. Really appreciate it. Great. Just from my side, yeah, my name is Graig Risi. I am the head of engineering at Old Mutual. So I'm just going to be sharing my slides quickly, and then there we go. Thank you. So yeah, today we're going to be talking about building automated quality gates into your CI pipelines, and I think really this is something which I feel is one of the benefits that we get out of the DevSecOps process, is that it actually gives us a lot of control within this process. And the reason why I think it's so important to talk about it is often I find when the moment you talk about a quality gate or some form of regulation, people can very easily just lose track of of the whole purpose of DevOps pipelines, because I think, but it's this process that slows us down. We need to be quick, and there's this like constant push to we've got to develop as fast as possible. How do we move code into production multiple times a day? We can't do this if we've got unnecessary steps and gates that are constantly blocking us. And so, yeah, I think a talk like this is useful, because what I want to try and do is showcase that having gates, having processes within your pipeline are actually healthy and a good way for us to go about thinking about DevSecOps, and a good way for us to think about software development and what it does. If we could just move on to the next slide. And so this is a bit about me. Like I said, my name is Graig Risi. I am the head of engineering at Old Mutual, where I think Old Mutual is a company that doesn't need any introduction. Many of us are familiar with it as a brand. What you might not realize is that we're quite a vibrant engineering place, where we have more than 500 engineers across multiple teams within Old Mutual, and we develop a lot of software in the financial space. And those 500 engineers are just scratching the surface of what it is we do. If you include some of the stuff that we spend on analysis, and look at some of our data and support teams, we're easily touching over 1,000 people that are involved in developing software as an organization, which I think for a company of our size is pretty large, but it really allows us to be able to be effective at what it is we do and be able to drive value for our clients. But I also see, you'll also see something else in the bottom right corner there called risky games. So if you're a board game lover, I also do board games, and so I have my own board game company called Risky Games, where I've published up 12 board games already from a variety of different types of board games. So if you do love your board games, please go ahead there and you can download them. They're for free because I believe in open source technology. So my games are free too. Next slide is just really just talking about my book. And as already shared, I've got a book out called Quality by Design, and this is a book that really looks at how do you develop software quality, all the way from conceptualization through to testing. I think sometimes when we think about software quality, too many books tackle it from the testing side. I wanted to look at it from the actual foundation side, where we actually, how do we build software, right? How do we build it with quality in mind? And part of that, if you go to my book, is also talking about things like quality gates and automated quality gates, because I think that's a vital role. And so I think, in reading the book, you'll understand holistically how to take software from design, but also through building quality gates into the process. It will also help you to get to better quality software, along the way. But what is a quality gate? And I think my next slide, I really want to just talk about what is a quality gate, and really it's about a change control. So when we think of quality gates, I would simply try and think of it as a change control or some sort of entry exit criteria. Typically, when you think of from a testing mindset, testers would always think of what needs to be ready, what needs to be done in the software in order for it to be ready, to make it ready for me to test, and should have entry criteria to enter the test phase, and then an exit criteria. So it's almost like you pass in the ball from one phase to another. And that's really what a quality gate is. It's just a safe passageway to be able to say, I'm ready to pass the ball to another person, but I need to make sure that before I pass them, I'm not passing something that's going to make their job bad. So as a developer, I shouldn't want to pass on code that is going to fail at the very first time a tester opens it up and tries to test it. There needs to be some level of quality within the code that I've produced that makes that person's job better. And I think that's an important thing to understand. So that's really what we're trying to do. It really prevents development from moving to the next stage until certain criteria have been met. We want to be able to pass the ball safely so that as we say it's ready, how do we know it's ready for the next phase of our CI/CD process? If we're passing this ball from one environment to another environment, how do we make sure that it's really ready for that environment? And it's the level of checks that that we can put into place to make sure that we're building quality into the process from the beginning. And that last point is really, it's also something that we can automate. We think of quality gates and we think of general process as these things that are hindrances, but the truth is a lot of the things that we want to check and a lot of things that we can check within our pipelines can be automated. And those things that do hold us up and those things that we might traditionally think of, oh, this is an unnecessary process, can actually be automated so that you can still have those checks and balances in place without breaking things down and without slowing you down. But in the next slide, you'll see that we all have our own sort of software development life cycles. And so this is just something that I wanted to kind of just showcase that, typically when we think of SDLCs, it's analysis, it's planning, it's design. All of these things are really vital. But when we think of CI/CD pipelines, we'll often just think of 4, 5, and 6, maybe 7, at a stretch 8, but often we're just thinking of 4, 5, 6, within what the CI/CD pipeline takes, where we're actually now looking at taking our code, we're pushing our code through, there's going to be some tests that run in it, and it's going to deploy somewhere, and then we're done. The CI/CD pipeline is done. It's done its job of continuous integration and continuous deployment. And this is just really an example of any sort of software lifecycle. Now, this is your generic software lifecycle. Now, if we're running an agile team that's running 2-week sprints, that means you're repeating these things constantly all the time for each user story multiple times. That disposal might not be there because we shouldn't be throwing things out. But the point is, at some point in time, software will always cover these things. But because we're trying to do this from an agile perspective, it means that we're constantly doing it fast. And the only way to really work fast is if our CI/CD pipelines are only thinking of 4 to 6. There's a whole bunch of other steps in our life cycle that are slowing us down. So we also need to be thinking about, well, actually, how do we make 1, 2, and 3 traceable? How do we make sure that we're doing 7 and 8 better so that our pipelines are more effective and that we're building quality into it? But you might still be thinking, okay, so I know what a quality gate is, but I still don't understand why I need it. And so the next slide really just talks through why we should be getting a quality gate. So firstly, it's a measure to also make ensure that acceptance criteria are met. So again, we don't want to pass on bad quality to someone else. Why? Because if we're passing on bad quality to someone else, it's affecting the work that they're doing. But what it also just means is means that I didn't do my job properly. We don't want to get to a point where we're fixing defects too late in the cycle. The whole point of DevSecOps is to try to get better quality code through the process to try and get it faster. And so we need to make sure that there's a way that we can automatically check on that. Yes, there's code review processes. Yes, there's things where we can get our testers to sign off and give a thumbs up and say, yes, I'm happy with it. But how can we automatically ensure that the acceptance criteria are met? Are there measures in place, things that we can check, that we can do this automatically within our pipeline rather than have a process where some person has to sign off and say, yes, I've reviewed this code, it's good to go? Is there something that we can do to move it along faster without breaking that trust that we've done our job properly? Is there a way to move something from a test environment into being ready to deploy without the tester needing to say, yes, I've checked it manually, everything's good, but a way that they can do this automatically? And I think that's important. And having quality gates is there because it allows us to be able to do this step, but in an automated manner. And it's a nice way within our CI/CD pipelines that if we can build trust in our CI/CD pipelines, we can build trust in our code, and it allows us to go to production faster because we're now trusting the code going through our system. Often these manual steps that slow us down, these processes that companies introduce where we need to have things signed off and checked, is because the company loses trust in our CI/CD pipelines. We've deployed to production too many times with errors. So by having quality gates that are properly done within our pipelines, we can actually deploy faster, and it's actually better. Another great benefit of quality gates is that it actually drives a proper shift left mindset. We often talk about shift left in software development, where we're trying to bring testing left. We're trying to think, how do we catch defects? How do we get involved in testing a lot earlier? When we're using quality gates to be able to do that, where we need to actually measure what's going on at a developer stage, what's going on at an analysis stage, what's going on at the testing stage. Every part can now be measured. That helps us to be able to drive a proper shift left mindset. We're not just thinking about quality later in the cycle. We have to think about it from the very beginning. The moment we're starting our process, we've got to think about quality in mind, and that's a really good help. It's a really good driver to help you drive shift left. If you're an organization that's struggling with trying to do the whole shift left mindset, start putting quality gates into your pipelines, and you'll find you'll automatically get there because it forces your team to start thinking that way. It's obviously a safeguard against poor quality code impacting later cycles. When we find issues later in a cycle, it's more expensive to fix. It's a lot more time wasted. The quicker and sooner that you can get things working the way they should, the better it is for your software development. It obviously prevents testing being impacted later in the cycle as a result of that, and it ensures proactive quality. And I think that's that last part that I like. Often we can respond too late. We respond to issues, and I find a lot of software development teams tend to respond to issues. Something's gone wrong, let's address it. Someone found an issue, let's fix it. If we start to think about how do we build quality gates into our CI/CD process and look at automating them, we're now starting to build proactive measures where our team can move forward and constantly focus on building forward development because we know we have quality gates that will catch the issues for us. And we start thinking about it proactively because we're thinking about these things. And now when we're starting to design our software, we're designing our software with our quality gates in mind, and it forces us to think about software quality more proactively, which I think is healthy. But yeah, if we go to the next slide, again, we understand, okay, now why do we need them? But now what do I need to be able to build quality gates? And the truth is, I've said a lot of things about why we need quality gates, but that doesn't necessarily mean that you might have everything ready to be able to put them in place. So how do we start implementing quality gates into our CI/CD pipelines? And the first thing is we need to have well-defined and clear completion criteria. And I've put this first, not because it comes first in the cycle, but because I think it's often the hardest thing to get right, but one of the most important things to get right. It's very difficult to build quality gates into our process if we don't actually understand clearly what it is that we need to build. I spoke about how we don't just have CI/CD pipelines running through just a part of our lifecycle. We need to be thinking about how do we integrate even things at an analysis phase into what it is that we do. And the reason why I think this is important is even if you don't have your analysis sitting within your CI/CD tooling, it's something where you can still come in and see, well, okay, if I'm going to be shifting left, then I need to be aware of trying to get a high code coverage. And typically, this might sound quite excessive for some people. I've typically gone with like a unit test coverage, for instance, of 90% with some teams that I've worked in and said, you've got to hit a 90%, all the developers need to hit a 90% coverage. How do you hit a 90% code coverage without really understanding what it is? That means I must just have an understanding of what I'm building. What are the scenarios I need to think about? How do I need to go about in terms of understanding how my application needs to behave from a positive scenario, from a negative scenario? How do I then, if I'm going to have a quality gate that's automated for my testing team, they also need to have all this information. So what information do they need to test? Now, they're not going to be writing unit tests. They're going to be writing integration tests. What's important to them? They need to have some form of, if it's an API, they need to have a very clear API structure of what it looks like, both positive and negative. What are the different types of error messages that can be produced? What does it look like? What information needs to be logged? Because that's a test in and of itself. These are things that we need to start asking ourselves, and do we actually have enough information when we start building to be able to do this? Because if we're thinking about an automated quality gate, we need to make sure that the quality gate is met. And if we're going to have 100, high code coverage, have completely automated tests passing, I think we need enough information to be able to build those tests in place. And so that's an important thing. So having some form of well-defined, clear completion criteria is something that's very important. We need to have architecture that's testable, and I think this is again another key component behind building quality gates. Quality gates are built around the testability of everything. Everything's got to be testable. Our software needs to be testable. If we are struggling to test our software, then there's a problem with the design of it. And often I ask us, do we need to re-architect? And this is not just talking about it from the tester's perspective, because obviously testers need things like test IDs. They need to have very clear. You can't just say you need to test this button. They need to know what's the test ID of this button, what are the properties of the button. If I'm going to automate this test, I mustn't wait for the button to be finished development and now do it, because then we're breaking the chain of the CI/CD pipeline. We're now doing automated, we're like now doing manual testing as the thing, and we want to build this into an automated manner in order for our software tester to automate a button, they need to know specifically everything about the objects of the button to be able to do it. And at the same point in time, that helps the developer build out more information because now they have more information to build a better button. But then it's also from a unit test perspective. If you're a developer and you're struggling to unit test your code, and I've often seen this where developers are like, "This is taking too long. I don't know how to get a high code coverage. This is too difficult to unit test." Well, I'm like, if it's too difficult to unit test, you've probably designed it wrong. If you cannot unit test your code and get it to a high code coverage, there's a good chance you've designed it wrong. Go back and revisit it. How do we design it better to make it more testable? It forces you to think that way. When you've got a high code coverage you need to hit, when you've got completely automated testing that you need to get to, with you need to think about how do you make your architecture testable. There is that then strong focus on unit testing. It's very important. If you're an organization where unit testing is not handled well by the development team, that becomes a problem. You've got to change that culture. You've got to put in unit testing. It's got to be critical that you put unit testing in place to be able to drive that. It requires automation throughout the process, like I've already said. You've got to be able to automate everything within the process. So if you're going to have manual steps all the way along, like we can't go on to the next step, we need the testers to now go onto our test environment and do some manual end-to-end testing. It doesn't help your CI/CD pipeline. You're stopping the process, and your CI/CD pipeline is just becoming a CI pipeline. It's not even getting to the deployment process because you're not actually involved in the process. So again, it requires everything to be automated, but it also works best for small, frequent releases. And again, this is another vital point, because if you're an organization or a team and you're constantly thinking of these big, and you're building these big end-to-end cycles, and you want to introduce DevSecOps to be able to help you streamline these things, that's not going to work. DevSecOps by design won't make you faster. What makes you faster is breaking things down into small chunks, and DevSecOps works best, and CI/CD pipelines and quality gates work best when you're working iteratively, rather than make 100 line changes and then pushing it through a pipeline. Just make 5 line changes. Just change one small part of the feature, push it through a CI/CD pipeline. It's passed, it works. Then do another one. So you're releasing little feature by little feature over time. It's actually better for you than trying to release a whole bunch of features and then try and test them end to end. So this works best when you're focusing on small, frequent releases rather than these big bang stuff. Great, but let's look at the next slide. So we've got the building blocks. We've got testable architecture. We're now focusing on smaller things. What do we do next? So what are we actually now trying to check? What is a quality gate check? So a quality gate looks at things like your build health. What's the health of your build? You're building your code. It's compiling somewhere. How healthy is that? So, are we happy with what it is that we built? It's looking at your infrastructure health. So I've got to deploy my code into a test environment. What does that look like? Is that environment itself healthy, or am I actually deploying healthy code into a bad and unhealthy environment? That's not going to help us be able to test our code. So you actually want to do some stuff. So it should measure your infrastructure health. It should obviously measure your test results, and that can be your unit test results, your integration test, your end-to-end test results, whatever it is. All of those test results should be measurable. Your code coverage. So we're not just looking at the test that we're executing and making sure that all passes, but what's the code coverage of things that are passed? It's a very important thing to have in place. And so that's something you've got to measure, and your quality gate needs to have a look at code coverage. We should have a look at our scans, your security scans, your linting scans, your scans around just trying to make sure that everything is matching and looking right according to your coding standards. Is that all in place? It's very important that we look at that to make sure that we're developing things according to secure best practices, that there aren't any security issues that we're introducing, that we're not using open source packages that are out of date, but that we're keeping things up to date, and that we're constantly moving on to newer packages. A lot of our scans can tell us this information. And if you're working in an organization that's not treating security seriously, or that's struggling to deal with their technical debt, you can often change that behavior by introducing quality gates that prevent packages that are too old from being pushed through. That then forces them to go, hang on, I need to now start updating my packages because this quality gate is stopping me. And you can start to introduce some of that stuff. And so that's important. Service performance and how things are performing. We can actually do some NFR checks within quality gates. I think sometimes we think of performance and load testing as something that gets done as a separate stage outside of our CI/CD pipelines. But there's an element of that we can actually look at at service performance. How long does it take our code to execute? How long does it take to execute if I execute 10 10 pieces of this parallel. I'm not saying we're going to do full load testing in a CI/CD pipeline. We just, that's going to break our pipeline. But we can tell a lot about when the code. So if we're measuring our CI/CD pipelines and we're saying every time your code degrades to a certain degree, I'm going to run this script, and if the script is now all of a sudden slower to a certain level than the last time, I'm not happy with that. I'm going to say that something happened, and then you can split it out and maybe run it 5 times and be able to see, am I happy with this? And so there's an element of service performance that you can also put into your pipeline, and that can become a quality check in and of itself, so we're not introducing slow code into the process a lot as well. And then there's things like incident and issue management. You often hear of teams deploying into production, but they've still got major issues that are outstanding that they haven't addressed. The pipelines have all passed because all the tests have been written, but hang on, there are still some things that need to be fixed that we haven't got to, but we never wrote a test for it, so the pipeline's all good. But we actually still want to go back. You can also include, incident and issue management into your pipeline to actually go check. These are all the user stories associated with this release, but there are still defects outstanding that are associated with these user stories. I'm not going to deploy because there's something outstanding. Please rectify it. Again, forces your team to go ahead and actually fix issues and fix defects to ensure that what's getting delivered and deployed into production is healthy. And those are things that we want to try and do. And those are healthy things. If you go to the next slide, it unpacks it a little bit better, just in terms of saying what are the steps that we want to do. So types of quality gates in place. We can put a quality gate at the setup and checkout phase. So you can put a quality gate before code even reaches your pipeline. You can already have a quality gate that says, I'm going to check this code and make sure that I'm happy before I even do anything that this code is in the right order. That from a setup and checkout perspective, I'm happy with it. Now I'm going to build this code, and then I'm happy that that's built successfully. And there's some stuff and checks that we can put around the building of code. Then I'm going to execute it, whether it's a unit test or a CI test, however you want to do it. Am I happy with the output? I'm going to check that. I'm going to do my static analysis scans. Am I happy with that? Before I deploy it into any environment, I need to then go and check, am I happy with this environment that I'm going to deploy it on? If not, I'm not going to deploy it because the environment's not ready. There's something there. Maybe there's a dependency, like I'm deploying an updated version of an API, but it needs another API to be at a certain version. That version's not there. If I deploy this new version, it's going to break the system because something that it needs is missing. Those are checks that we can put in place to say, don't deploy. This is not ready for you. And then we can check the environment both pre and post deployment. So both pre that deployment, just do a quick check to make sure everything works. And now that we've posted, we can see, oh, there's consistent results. We haven't broken anything from these critical tests. So we can have that satisfaction. We can then obviously run further automated integration tests, further levels. We can then do even dynamic code analysis. So if we think about our static code analysis, often what we look at when we're doing our security scans, what about the dynamic code analysis? Things like mutation testing, have we considered that? Have we built that into the process? Again, that's the type of quality gate we can introduce. And then even non-functional test execution can be a quality gate of itself. I spoke about the example of performance. Are we measuring the performance of how long something takes to execute? If something's degrading along the way, then that's something that we should be able to pick up. And so those are things that we can start to introduce within our testing phase, and that can actually be introduced from a quality gate perspective. And so, on the further slide, on the next slide, I'm going into a little bit more details on just some exact examples. So on the next slide, there are things that are put in place, like, again, your linting standard. So this is a specific clear thing. So what does it look like? A linting standard needs to be met before your code can build. Something simple like that, so that if your developer is not following best practices, you can actually scan the code and say, well, hang on, there's some just simple best practices that they haven't followed. Just the way that they've done their naming convention, it doesn't match the way they were expecting it. You can check all of that before it even goes. There are some rules that you can put in place before you even start introducing the code into your pipeline process to say, we need to be happy with this. Obviously, things around your unit test. Are we completely happy that all the unit tests executed, and do we have a high level of code coverage? And I've always used the example of 90% as a good sort of grounding. You don't have to use 90%. It really depends on where your team is at. If your team's got no unit tests at all, I would say start with 20 to 50%. Just to at least get them into the habit of it, and then you build yourself up from there. If you're working on legacy code where there are no unit tests existing, and it's a legacy piece of code of 10,000 lines and you're just making one line change, and now you've got a quality gate that's got to get 90% code coverage. It's probably not suitable. So again, be flexible in how you measure this. But the point is there needs to be some check in place to ensure that the work that you've done, can be unit tested. You obviously want to have 100%, completion of your scan. So your scans should run. Your scans should be able to access all of your code. And I think that's not too bad to ask, to be able to ensure that scans can run on all the code that's there, and then you can determine what the failure is. And I'll go into an example later on where we look at an actual YAML file and ask it to check something, and then it doesn't need to have everything being perfect, but it needs to at least make sure that everything is scanned, and that you've got some sort of level measurable output that you're happy with, to say we've run our scans, we're happy with the output. And then successful pass of your automated checks. If your testers integration and end-to-end tests are failing, investigate that. Don't just assume that everything else passed. I'm happy with my code. We're going to push into production anyway. It's failing for a reason. Understand that reason. You put it into play. So make sure that you actually check and investigate those things. Because again, if our pipeline is failing somewhere along the line and we're still just pushing code, regardless of that, and we're saying if this fails, but we're happy with 90%, I would say you got to be very careful with that 90% of end-to-end and integration test fails, because often your testers, the tests that they're writing at that integration there are very critical. So you also want to make sure that all of that passes before you deploy into production, because those debatable scenarios should often fit at a unit test level, not at an integration test layer, and those are the things that you then want to be able to check. So very important again, to put in place. And these are examples of some quality gates that we can put in. So if we go to the next slide, this is an example of thing, and this is not a slide I come up with. This is a slide that you can, a picture that you can easily find on the internet. A very common sort of checkout that we can do, that most people do. Here's one where you have your setup and checkup, where you've got your Maven set up, and you've got a quality gate that actually just checks out the code, make sure the code is happy before it builds everything, runs your build, runs your unit tests, runs some CI tests within there, then it moves on to your static analysis code, where it's doing a dependency scan, a quality scan, a security scan, coming through to make sure that everything's happy before it deploys it into a QA environment, runs the tests, gets the correct answers. Then there's some sort of dynamic code analysis where it's now doing some mutation testing, running some things against the actual environments, trying to see if it's happy with that. And then once it gets there, it then deploys to an actual staging environment where it then runs things. And then before it gets there, there might be some additional sort of accessibility testing, things that, these are all checks that you want to put in place. This is a common sort of thing that you want to do. The question is, how much of this is automated? How much of this do we actually put into our pipelines? But the truth is, you should actually have all of this in your pipelines. And if you go to the next slide, I break it down into even more detail in saying, well, hang on, it's not just about those phases, but what about things like your analysis? You've got a quality gate one at analysis. When I'm getting a user story, what needs to be in a user story? Sometimes, and we can't check everything, but what we can check is to make sure that the user story contains error conditions, that the error story, sorry, that the user story contains certain information that needs to be populated within our ticket. We should say, well, hang on, before we even start working on this, let's actually just go and check. So before you're even allowed to start working on something, you can already block something at a level to say, we're not ready for this because there's information missing. So you can even have quality gates that you can build. It might not be in your CI/CD pipelines, but you can build a quality gate into your, into whatever sort of suite that you're using to drive your user stories, whether it be Jira, Azure DevOps, GitLabs, to just say, before you even move this user story to the next phase, something's missing. You're not happy with something, and you can write code that can check that to say it's not ready. Then once you get to your code development and everything, it's, you then follow those things where you're doing your conditional checks, you're measuring your code coverage, you go to different quality gates. But now we move from test environments to we're building something ready, and now we get into our prod environment. But now when we deploy into prod, do we actually then check? We've now deployed into prod. We need to make sure that there is some form of accepted testing. Obviously, user testing is something which we can't mimic. We sometimes need our users to test the stuff. But what are we doing from an acceptance testing? Have we automated that? When we actually deploy into prod, are there tests that are actually running into prod that are doing things? And then even things when we think about our commercial use, when it comes to incident management and problem management, is that something that we're building into our CI/CD pipeline, that when when issues are raised against something, what happens with that process? It gets logged, it gets checked, then we have a manual board that we could try to it. How do we link that into our CI/CD pipeline process? It's also something to think about, because it is possible that if an issue is raised and you're using a tool like Jira and they've logged an issue and that linked to this part of the code, we can now go back and check, and we can actually bring that into this thing and say, okay, well, now this is checked, and we can build that into our pipeline process to say, okay, now this is going to run, and it's going to run all the tests against a particular issue. Or it will then just kick off and say, okay, this is now going to be next on our board, and you can introduce some way of being able to check that all issues that are now outstanding are actually properly closed off, and we start bringing them into the thing where you now see, okay, well, there's now this job that exists, and we've added it to our board automatically because an issue's been logged and it linked it to the story that it was in, and it's given us all the information we need. And now that becomes a user story that's automatically populated with all the information that is pulled through our entire process, and it just helps us to be able to focus on now being able to fix these issues better because we have all the information at hand across the process, because we have all that data. It sounds convoluted and complicated, and these are things that teams should only get to very late in the cycle. But the point is, these are things that we can put into quality gates and things that we can build. So how do we build quality gates? I'm going to very high level in the next slide just show you this is an idea of if you're using Azure DevOps, some things to just be aware of. Some things where you have an Azure board, you're a developer, you have some sort of Visual Studio Code that you've got some sort of Azure repo that you're building, and now you're triggering the build. Then it's now got to check something. It's got to trigger your release, and it's got to build your artifacts, and you put it through different stages. I think everyone fundamentally understands that. If you're new to DevSecOps, this might be something new to you, but I think all of us will pretty much understand these things, that we'll have a job, and every job, every trigger should trigger a level of jobs that now need to be met. Now we manage that as developers, often through our pipelines and through our YAML files. And so, I'm now going to go into the next slide. These are going to be some actual examples of just some simple things that you can do and build into your quality gates to be able to do. So here's a pre-deploy test where we're saying pre-deployment, how do I check that certain things in my environment are ready? This is a very basic one, but now what I'm just doing is I've got a task and just saying before I'm even deploying, I'm actually running some bash scripts just to check that certain things are up. Again, we can go into more detail, and you can actually check APIs. You can actually check that APIs are returning a 201 when you ping them, and you can even ask to not just ping a 201, but that certain fields exist within that API. There's a that's level of detail we can go into checking for that. But this is just an example of a very simple one where I'm just simply saying, I want to check that my environments are up before I deploy. And then what I'm going to do is then after I've deployed, I'm now going to actually run some bash scripts again. I can either run the same stuff, or I can now actually, okay, I've now deployed, and now I'm going to run a whole bunch of set of tests to just check that it's working, just a smoke test. Here we're using a bash script, something that we've just written because we just want to test some clean sort of environments. But again, this is an example of a very quick, simple quality gate that you can put in place that just to make sure that your environments are ready. And so things that are critical in your environment will obviously look more complicated than this, but it gives you a good sense of the things that need to be done and checked. And you can again just assess it within your environments as you go ahead. The next slide perhaps gives you a little more of a different detail of a real sort of YAML file where you can go into. So here is something where we actually got a report generator, and what we're doing here is we're looking at our code coverage. So here we're running Kobatura against our code. So we've got a report generator, which is really just looking at the report running after the like tests have run. So we have a publish step where we're publishing the code coverage report, where we have a task that sets it up, and it's basically telling it what code coverage tool to use. It's telling it where the results files are going to be checked, and then it basically just says, well, I'm going to have a look at this task, and based on this task, I'm going to go have a look at the result, and we've set their code coverage target 90%. Just by having code coverage target 90, that's something that can check. The moment the code coverage target is not 90, it fails. So that task is to go have a look at that file, look at that folder where our results from our Kobatura report are stored, actually go check it. If the coverage is not 90. It's going to do it now. Depending on how you've set up Kobatura, it might be looking at your blind coverage or decision coverage or branch coverage. Typically, you'd want all of them to be measured and then to get a result from that. But the point is, here's something where the simple step like this in your pipeline can force developers to need to rethink their unit tests and needing to hit that. The next example YAML file that I've provided is something now when we're actually now looking at some scans, and so on the right hand side is just some of the actual sort of code that you'd be using to actually start running the scan, and some of the things that you're going to use to set it up, just about the Docker image and setting it up and what it needs to run. On the left hand side is an actual sort of script that you can now put together that says, okay, I'm going to have a look at what are the accepted values. So I know what values, critical, high, medium, low, I get from my scans and what it tells me. And I've got violating severities. Anything that's critical, high, or unknown severity, I need to be aware of. And so, basically, when they're going to say that it's going to fail, is safe match, and it's going to fail if it contains any of those violating severities. So every time my scan runs and it picks up something that's critical, high, or unknown, whether it be a quality issue or a security issue, we're going to flag it and say, can't deploy, there's something there that I'm not happy with. And again, these are quality gates we can put in place that can prevent bad stuff from happening. And something like this, again, very easy mechanism. Once we have these scans in place, it's a very easy mechanism to prevent anything deploying that you're not happy with, and to make sure that we're catching issues before they happen, that we're not deploying something into production, and then later on we realize there's actually a security vulnerability in there that we forgot to check. It's automatically checking it. It's something that you're building into the process, that it always needs to be checked, and it forces your team to always do the due diligence, and forces them to always try and keep the pipelines green, and forces them to always be on top of the big issues. You are sometimes going to get issues on scans, for instance, where you can't always tackle the critical or high issue. You can also build some of these measures in where you can have a manual step in the process, which will then say, okay, we are going to do it. But those manual steps should really just be there only as extreme measures. Should something significant happen that for some reason you just can't get a quality gate to pass, but other than that, you can catch these things. And so I think that's very important, and I think something to put in place. But then the last point I want to talk about around CI/CD quality gates is on observability on the next slide. So it's not just about building things into our pipelines. So quality gates are important, but the real value you get out of CI/CD pipelines is that constant data that you get, and you're running your code back and forth multiple times. And I think we do a lot of observability on our applications, but we don't always do observability equally well on our pipelines as well. And I think it's important to use that metrics that we get from our pipelines that are constantly building and running our code to be able to better understand what's going on with that code. So, it's very important to do that. So it's important to, from an observability perspective, collect your data from multiple sources. Your pipeline will typically be one tool, whether it be Jenkins or ADO. Again, that's now running that pipeline, and you've got the pipeline that's now working somewhere, and you're collecting that. But then there's also other information that maybe your tests are running and they deploy somewhere else. There's maybe some monitoring somewhere else that's collecting information about the application while it's running against the different environments. That environment information is very useful to take that information and store it. It's important to take that information and store it in a central place. And the reason why I'm saying do that is you want to get really valuable data out of your CI/CD process. Don't just rely on the tool's own observability things. Don't just use Jenkins reporting or ADO reporting dashboards to check your pipeline effectiveness. The truth is that ADO and GitHub and Jenkins, their default reporting only gives you so much information. You can get more information by being able to correlate the other things you're picking up through your other tools, whether it's what's actually going, your underlying environment scans and the tools that run in there, bring those results in, what's actually checking how healthy your different clusters are and your containers are, and what's their CPU usage and their memory usage while your containers are running in the pipeline. That type of information sits elsewhere. Bring it in to a central location so you can collate all these things together. Use APIs to help with gathering that stuff. You don't have to pick it in manually. All these tools will often have APIs that you can plug into to gather that in. What are your logs going on, and those things that we're monitoring through our logs, pull some of those logs, and those are things that we can build into, again, just data. And then we can use that to visualize things. So whether you're using Grafana or some sort of other Dynatrace tool, you can now use it to visualize not just what's going on with your application, but understanding your application while it's running through the pipeline process to see what can you pick up. When I'm running my CI/CD pipeline, is my container performance satisfactory? Am I happy with how the output is? I'm getting a spike all of a sudden when certain tests are running, maybe not to the level that it's failing something, but let's investigate that further. Let's find out more information. I think we sometimes don't do enough of that. But let's use more information. Then we can also do things around set up when things do go wrong. So when there is alerting, when we are picking up things from an observability perspective, not just that our pipelines failed, but maybe something else was picked up along the way within that, just make sure that we, it can alert us when something, when we do get this information. And then, obviously within that process, just, keep track of your data retention policies. If you're going to be tracking and keeping all of your pipeline data all the time, that's going to very quickly ramp up to a lot of data that you want to get rid of. So the idea is to just get rid of that data very quickly, take it, analyze it, but I wouldn't keep that data for more than a week or two. But the point is, there's a lot that we can gain from even just observing our CI/CD process, and from an observability perspective, that will help us to get better, because we're constantly learning, we're constantly monitoring and optimizing not just how our software operates in production, but how our software performs during the whole sort of testing lifecycle. And that's really interesting information. But so I think all of this together will hopefully paint a good picture of what a quality gate is, why we need a quality gate, some of the quality gates that you can build within the process, and to the nth level that you can go to. If you want to get really granular, you can really put a quality gate around everything. But even if you just want to do simple stuff, I think it's very easy to go into a YAML file and write these codes together, and then to tie it all in to build observability into the process that you can better understand things. But that's the end of my presentation, and I think we can move on to the next slide. Is just purely just for questions. So, yeah, please pop a question. Really keen to hear from everyone. I'm gonna. Is it okay if I just start reading, or are you gonna? Do you want to have some sort of filtering process, Kallie?
No, you can go for it.
Okay, I see Stephen Little's got some questions there. So dev teams often work with unreasonable deadlines. This is further exacerbated when security issues are pointed out, or builds have failed automatically due to that. I fully agree. I think that's a common issue to have, and it's definitely a culture that, in my opinion, is not healthy. But I think there's a lot of teams that have that, because we're constantly, focusing on delivery. And I definitely think that what a quality gate tries to drive is that it makes quality the focus and not just the delivery. And that can be quite frustrating when we have things like security issues pointed out. But my sort of argument to that is, yes, your quality gate is going to fail. There's a security issue. It's going to slow you down from a delivery perspective. But what's important? Is delivery important, or is your quality important? If delivery is important to you, then that's a bigger concern you need to have. But the idea is, at least your pipeline worked. It actually stopped something. It actually caught on. Okay, we have a security flaw. Let's fix that. Yes, it might slow you down, but at least it's making quality that central conversation. And the pushback I always push back to the business and to organizations is, we shouldn't be expecting our developers to just deliver against deadlines. We should expect them to deliver against quality standards. The only time, to me, a deadline is ever important is if it's legislated. If the law is telling us to do something, needs to get done by a certain date, then it needs to get done by a certain date. But outside of that, I think we sometimes rush our deployments too much. We want to be able to deploy every day, but let's rather keep that quality mindset going. And I think that's just a frustration that's there, and I think that's a common concern, Stephen. But I think building at least quality gates into the process and checking these things at least creates the right mindset around quality. The next question is then, when we start hearing terms like blocker, etc., how do we change the mindset to security? That is a good question, because again, it's that it's that blocker, and I think from a security perspective, what is a blocker? And this is sometimes things that we can configure within the tool itself. What is a blocker? I do think that sometimes security tools, if we don't configure them correctly, you can actually set the sensitivity that you put to certain things, and what really is a blocker is a question we've got to ask ourselves. And then also, where is this found? I've had issues where our security scans picked up a whole bunch of blocker issues for an issue with the test framework, which was never going to be deployed into production anyway. And in situations like that, it's like, well, that actually is not important. So we actually, had to write something to say, well, skip that. Don't actually, if something's not going to get deployed, these are the libraries that never get deployed. We're okay to live with that. Move forward, and you can actually then write things which actually exempts it, and just puts it in place so that you can actually have control over the thing that you can do. Not everything's a blocker, but where valid blockers are, I think we need to address them. But yeah, I think we definitely got to change that mindset around security. It should never be a blocker. To me, a security issue it really saves a lot of time with the company. And if people are having concerns that a security scan has now failed and it's going to slow them down because there's something there, that scan shouldn't be seen as a blocker. It should be us doing the job right. Security is one of those things that people can get frustrated with, but the moment you have an issue, and I mean, I'm working in the financial space, if you find a security issue in the financial space, it's going to hit you hard. It's a lot of money. It's a lot of reputational risk. We can't afford for things to be problems. And we've had, experience, in many companies I've worked with, where you do have security issues. They do come. They do expose things. Clients lose money. We can't afford that. So to me, it's like a non-negotiable, and we should, again, help our organizations to think about quality and security first over deadlines. And these are good things. And this is a hack. It's a naughty hack. It depends on where you are in your organization. But if you're in charge of DevOps pipelines, you can sometimes block. Yes, you can stop an organization from releasing things, but again, that prevents bad habits. And even if the business says yes, let's go ahead, if the pipeline doesn't pass, there are sometimes rules that you can put in place that can even prevent a manual check. And I've done this in the past when I'm trying to change bad behaviors in an organization. I take control of that. So even if the business is saying we need this to go live, I'm saying it's not going to go live until the pipeline passes. It's rude. It's harsh. I wouldn't do that unless you're in a certain level within the organization. But again, it's something to be able to address. But we do need to change that mindset. Alroy's got a question. Are there any form of metric guides to measure existing systems against, I suppose, similar to DORA metrics, but for a measure of quality gates? DORA is one of those things. I think DORA just measures a portion of it. But I've looked at other things. So some of the metrics I've looked at is obviously metrics around your code coverage is a good metric to have. Are you as a team, are you measuring your code coverage? Actually giving teams a score for their code coverage and then putting them against a thing. So it's not just DORA metrics that they've got to get, but they've got to get their code coverage metrics passing. I think are some things that we can put in there that I think are quite useful. I think there's definitely things around making sure that you have the different quality gates implemented. So what I've also done in the past is I showed a slide where we have like 7, 8 different sort of quality gates, and they each do something. Actually making sure that each team has those quality gates in place is something that you can do. So you can actually then score the teams on they've got the actual quality gates that they need, and every quality gate is in place. You can score your teams out of the security scan results and making sure that that's there and that that's in place. There are some things to do. DORA is definitely helpful and measures things. You can also measure the overall defects of a team. Both in sprint and after sprint, and use those as things that you can put in place. There are arbitrary metrics, but I think all of it tells a story. I don't think any one sort of set of metrics will be able to do it. But the point that you want to try and get into is team health. Things like your DORA metrics are part of that team health things that you can build into maybe your Jira processes, like I said, where you want to make sure that user stories are of certain quality that can help drive the right behavior in your processes. There are certain things that we can do that you can measure in your Jira or Zero DevOps processes that you can build into your CI/CD pipelines. Those are things that we can consider and measure as a quality gate. I think there's definitely value to that, and definitely things which I would recommend looking into. Great. Any other questions? I think we've had some really good questions so far.
Yes, I have a question from my side.
Go for it.
So I just want to find out. So earlier you mentioned Jira or basically planning sessions in the planning. So I just want to find out. So should development teams already specify in terms of what the quality gates should be in terms of the percentage that you mentioned, the code coverage, or the quality should be at least 90% before it passes, or what do you think? Should all those information be already mentioned upfront?
I think it should, and it does depend again on when you're introducing this stuff into the cycle. If you've got pre-existing legacy stuff and now you're introducing quality gates, you need to be very careful in how you introduce that. You can't just go for a high code coverage on things that are already existing. But I've done this, for instance, in a new team. So I was fortunate enough a couple of years ago when I was still working as a consultant for another company to work on a client where we were doing something completely new, and we could build quality gates from scratch. And what we actually did is we actually built our CI/CD pipeline structure before we wrote a single line of code. We actually built a code coverage quality gate to say it's got to hit a certain level before it does that. We put some scans in place and we set that up. We obviously put some environment checks in, but we couldn't do too much because we were still fleshing out how some of these things needed to work. But then we also were starting to put some quality gates in place in terms of what does a good requirement look like. So we started to build sort of like our API structure. So this was largely a backend system, and it was largely just Lambda functions and APIs. And so we were like, this is the things that are important to us. This is the structure that all of our APIs need to look at. So when we're building user stories and you're asking us to build stuff, and now we're sending messages, your user story has to include API messages and responses. And we know what the responses need to look at. So as a feature analyst, if I'm now writing user stories for my teams, I have a structure that I've got to hit. I can't just write this is an end user and I need to write an API that does this. I've got to be very clear and say, but this is my API structure. In this user story, the API needs to send this, this, and this, and this, and the output needs to look like this. So we put some guidelines in place of if you're writing a user story for this API, actually include the API message. We need to see how your user story would change the API message. If it doesn't, that's great, but we need to see these things. So it allows us as a team to very quickly say, we've put these structures in place. Now, again, this slowed us down, and we spent an entire month delivering nothing. It sounds bad, but once we started to deliver and once we put all these guidelines in place, we were operating very quick. We were able to deploy comfortably, multiple user stories, and we actually then started to measure all the teams. This company was measuring all the teams by story points. We were, whereas most teams were doing like 20 story points a sprint, our team was doing 40, 50 story points a sprint, just purely because we were able to get through so much because we put all these definitions up front. Now, again, most people are never in that type of position. When you're working in a legacy application, you have to work within your constraints, but then you start introducing quality gates bit by bit by bit. I think the security scan is easy to introduce. Your unit test is easy to introduce, but maybe you just adjust your percentage based on where you're at. But you need to say, for this particular module, if it's a new module, let's have an 80% coverage. If it's an existing module, maybe we're going to let's push it to 1 or 2% higher every single time we touch it. And you start doing something like that, and then you actually separate that, and you can put the rules in place for your quality gates, to be able to be specific, and then you can expand it from there. But again, I think if we start with the right base, but if we think about it up front, it helps us being able to put the right things in place when we get there, so that when you're actually building your user story, it should be already clear what needs to be achieved. Hope that helps answer your question.
Thank you. Yes, it does.
Thanks, Kallie.
Not sure if there's any other questions.
I see
Yeah,
Chris just posted something. Go ahead. Yeah.
sorry.
Kimberly.
I just wanted to circle back, since we know that adding quality gates in the pipeline is a bit invasive. You had mentioned, you are a bit further up in the ladder, so it's a lot easier for you to like put a hard no. But for those of the listeners here today who probably aren't, who are just like a regular security engineer, how can we like effectively address the resistance to the integration of quality gates?
And I think that's a good question, because it's hard to do change, and you're always going to struggle to introduce wholesale change. And I think an important thing is maybe you just identify in doing your scans, maybe just pick one team that is particularly problematic. What I've done in the past is, if I'm trying to work with within like an organization, I can't fix every team at once, but what I can do is maybe identify one or two pocket teams. And typically I would choose one team that's performing really well and just introduce quality gates and some things as an example of, let's just make them even better. But then I'd also choose like a team that's really doing badly. And I think from a security perspective, what are those teams that are constantly producing issues? Maybe some team that has had a lot of security faults in the past, and trying to say, well, how much time has been lost? Let's measure that. Trying to then have a look, well, we had, this team had 3 security incidents over the past year. How much time was lost at that? How much money did that cost us? And then we can start to justify that, speaking to the management team to say, well, if we introduce some of these things early, we can prevent that money, we can prevent that time loss. And then just putting a security scan in place. And again, maybe you'll be a little bit soft in terms of what it catches. We're not going to catch every vulnerability. Maybe we're going to set that we only want 90%. We'll accept one critical and 2 highs, just for the sake of being able to move forward. But at least it's something. And then you're starting to take from where they are and you're starting to reduce them. And all you need to do is win over one team and showcase the results, and then that helps. Once you have one team that's gaining value out of a process, and management can see the results and see the improvement, that helps you to then convince other teams to go on board. But it is a challenge, but you need to just at least work with that team. And I think where there are problematic teams, those are your ones to tackle, to say, I'm going to have a look at that and I'm going to try and address it as best as I can. Hopefully that helps. I know it's not easy, but I think we need to stick with it. But I think data is your friend. Try and gather as much data as possible in terms of the issues that they're facing. And then once you introduce the quality gate, try and add as much data as possible to showcase that we've now added value because of the quality gate. And if you can showcase that, again, that helps a lot. I think when we don't have that data, companies, things will always think, this is slowing us down. Whether it is or not is also the other thing, and it's the other thing as well. Teams will always think, this is slowing me down. Is it really? What does the data tell us? And I've often heard that as well. People feel like this process is making us ineffective. It's slowing us down. And then you actually have a look at the data and no, it's not. You actually realize that what was slowing them down was some bad code. It gives you the data to be able to prove that. So, if you have access to the data, let data be your friend. If you don't have access to your data, try and find someone who does have access to the data, who you can convince to be able to help you use data to your advantage.
Thank you, Craig. I know we have one more question in the chat, but just hopping onto that, piggybacking off the first question that I had, in what ways might we proactively involve the necessary stakeholders in the implementation of these quality gates, so as to promote the collaboration that DevSecOps is trying to achieve?
Yep. So one of the things I've been doing at Old Mutual, because I've only been at Old Mutual for 6 months, and these are some things that we're trying to introduce. One of the first things I did was we set up a COE around DevSecOps. And so I asked each of the teams to nominate a particular person from your team, who can represent you from a DevSecOps perspective. So there's a whole
Like
bunch of
security
names.
champions.
Security champions, even if they're not security champions, even if they're just CI/CD champions, they're just DevOps specialists and they're building pipelines for their teams. Someone's got to own that pipeline. Who are the people that like it? Bring them in. Then what we also did is we then also brought the security team in. So here we now having the center of excellence, the COE, the center of enablement, whatever you want to call it.
Yeah.
But it's where we now come up with community of practices, and now we're getting them to work together. Now having the security people in the conversation becomes vital, because now you start to talk about, but what are the needs within the organization? And it's amazing how you can scare people when the security team starts to showcase how many vulnerabilities are in someone's code. It can really be really scary, but they can say, well, hang on, this is how much issues we've picked up in code around the organization and things that we've been able to track, and these are the actual vulnerabilities that we're dealing with. Because I think a lot of times security, for the sake of I think it's the right word, but so security teams can tend to try and, for the sake of not letting issues leak, they tend to sit behind tight walls that they've built around themselves. And so, for various reasons, the security teams are trying to prevent companies from being hacked and all these vulnerabilities that have been faced. And I think many times they might do an incredible job, but no one knows that they're doing it because they're trying to do all of this behind walls so that these things don't leak out. Actually shining a light on some of the security issues that are getting faced in the organization makes a big difference. And within these conversations, we have the security team be frank on the issues that they're being faced and that they're seeing from their scans on the issues that they're facing on a daily basis. And that helps to then bring these challenges in. And so these champions now have to build pipelines. And now we're saying, okay, we need to come with a pipeline standard. What's important to us from a pipeline standard? Code quality is important, speed's important, but security is also important. And then how do we get that balance going? But I think it's important to try to bring that collaboration, try and bring champions in different spaces and actually get them talking is a key way to solve that.
For sure. Thank you so much, Kate.
No problem, thanks. And then I guess that last question from Chris Moritz. For a company starting to introduce quality gates, where would you recommend they start considering a legacy code base? I think that's a great question. I think, well, firstly, do you have pipelines in place? If you don't have pipelines, start building pipelines. But I think once you have your pipelines in place, I would say the first thing to do is a scan. Now, you can't use code coverage with a legacy code base because, again, you might be starting from a very low number. Having some sort of static analysis scan is a big way of being able to at least check the health of your code against certain things. So certain things from a security perspective that these scans pick up, I think is a good healthy way to be able to do it because it helps the team to think more secure in mind. Now, again, understanding that in a big legacy code base, you can't fix everything because it's going to bring a whole bunch of old code that's got nothing to do with your thing. But it's nonetheless, it starts that conversation and gets things going. And I think that's a healthy conversation to have and something which I definitely recommend getting more people involved in. So definitely something that you want to do. And I would definitely encourage getting security scans in place. But then from a code coverage perspective, I would still try and, if you can modularize your legacy code, that helps breaking it down into modules, and then you can run unit tests against just the small modules as opposed to it running everything. Again, it depends on how modularized you can break down. Often the legacy code can be broken down into smaller modules, and then you just, if you can modularize it, you just build a unit test for the code that you're touching. Or like I said, if you're going to do unit test coverage, just increase it by 1% every single time. Like if we've got nothing, even if I write a unit test for this new code I've just added to it, that's already 1% higher. Now the next person who's now going to be changing something that needs to just get it to another percent, you just constantly set it to 1% higher. It's going to take a long time, but you'll eventually get to a point where 60% is your code coverage. So those are some things to try. Hopefully that helps answer your question.
Yeah, so if there's, I don't see there's any additional questions in the live chat as well as Discord, but please feel free to, if you if anyone do have any additional questions, to add them in Discord, so we'll try to get those answered as well. Yeah, so I think that's it. I just want to thank you as well, Graig, for joining our virtual session today. Yeah, it was amazing. And yeah, so like I mentioned, please feel free to reach out to us on Discord, or if you do have any questions. Yeah, but that's it from our side. Thank you.
No problem. Thank you so much. Thanks for having me. And it was great, being able to answer questions, and hope people learned everything. And if you do have any questions, afterwards, you're welcome to reach out to me on LinkedIn, and I'll happily answer questions from there.
Perfect. Thanks, everyone.
Thank you.